I used the term variable in that previous section, and since variables are what we're going to be studying, let's take a few minutes to examine what they are. A variable, not surprisingly, is something that varies. It's a value or a characteristic that can be different from individual to individual. For example, if you ask a group of people their favorite color, you'll get answers that vary. Ages. Population. Now here, the individuals are not people. The individuals are cities or countries or some regions. Individuals don't have to be people. Now, variables are classified in certain natural ways, and sometimes that classification helps make decisions about how you should summarize the variable. So let's look at how variables are classified. The kind of variable we'll most commonly be dealing with is quantitative variables. These have numerical values, numbers, and numbers often come with units of measurement, as you know. These variables arise as answers to questions like how much or how many. For example, age, how many years? Annual income, how much money do you make? In the United States, a natural unit of measurement is thousands of dollars. Number of children, now this one's interesting. This one has no units of measurement like centimeters or degrees Celsius or dollars. It's a count. Quantitative variables are of two kinds commonly, though of course there are many other kinds as well. The most common is the kind of variable where you're willing to think that successive values of the variable can be arbitrarily close to each other. So for example, two people can be as close as you can imagine in height, even if they're not exactly equal in height. Such variables are called continuous. Typical examples are heights, weights, ages, and so on. Now in practice, we can only measure them up to a certain degree of accuracy. But frequently we say, it doesn't matter that we can't get completely accurate with our measurement. For all intents and purposes, these variables we are willing to consider as continuous. And then there are other variables like number of children. Now, number of children can be 0, 1, 2, 3. It cannot be 1 1/4. Variables like this, where successive values differ by fixed amounts, are called discrete. Just to be clear, discrete variables don't have to be whole numbers. For example, if a variable takes values 1/2, 1, 1.5, 2, 2.5, and so on, it's discrete. The values aren't whole numbers. Now, it's worth pointing out that these distinctions aren't hard and fast. Sometimes we will take a continuous variable and discretize it. For example, we look at age in completed years. That's a very natural thing to do. When you ask somebody, how old are you? They'll say 21. They're telling you how many years they've completed, and thus they've made the variable discrete. They're not telling you 21 years, these many months, these many weeks, these many days, these many hours, these many seconds, etc., etc., etc. And also, a little later in the course, we might take a discrete variable like a test score and consider it to be continuous when we're doing approximations like putting smooth curves over graphs of distributions. Be patient for a little while and you'll see when that happens. Now there are other kinds of variables. Some variables don't have numerical values at all. Rather, the data fall into categories that have no particular ranking relative to each other. These variables are called categorical or qualitative as opposed to quantitative. For example, favorite color. You ask a group of people their favorite color, you're going to get answers like red, blue, green, and so on. There's no natural ordering to red, blue, and green. You can say green, blue, and red, and it's all the same thing. Gender, nationality are similar. There are some special qualitative variables where even though the values aren't numerical, they do have a ranking. For example, if you measure temperature not in degrees Fahrenheit or Celsius, But just as low, medium, or high, a very coarse measurement, low, medium, and high are categories which have a clear ranking relative to each other. If you measure job performance, poor, satisfactory, excellent, there's a clear ranking relative to each other. Such variables are called qualitative ordinal because their values have an order relative to each other. But once again, these distinctions are sometimes rather fuzzy, and so we are not going to spend a lot of time worrying about exactly why one of them is called one rather than the other. And a word of caution, just because a variable takes on numerical values, that doesn't mean it's quantitative. For example, if your variable is favorite color, and your possible values are red, blue, and so on, you're perfectly free to assign a numerical code to those values. So you could decide that red is going to be 1, blue is going to be 2, and so on. But by doing that, you didn't change that variable from categorical to quantitative. And the reason is really that you can't do arithmetic with the numbers that you have assigned. For example, you've said blue is 2 and red is 1, and certainly 2 minus 1 is 1. But blue minus red equals red doesn't make any sense whatsoever. Taking the average of those 1s and 2s and so on does not make any sense. So the numbers that you have assigned are just labels. Just as the old words, the red, the blue, and so on, were labels. That's all they are. There is one interesting case though. If you have a question to which the answer is yes and no, that's it, no other possibility, just yes or no, and you assign the code 1 to yes and 0 to no, those zeros and ones are very powerful indeed. The entire online system, your computer, my computers, are all based on those zeros and ones. If you code your answers 1 and 0, then the average of all of your 1s and 0s is a very interesting quantity that we will meet later on in the course. Patience.